Morning, my dear students. Today's topic is the last steps involved in the metallurgical process. Let us see. Refining of metals. This is the last step involved in metallurgical process. There are 6 processes in refining of metals. Number 1, liquefaction process. Number 2, oxidation. Number 2, distillation process, oxidation process, thermal decomposition of suitable compounds, electrode refining and zone refining. Let us see the liquefaction process. In this process is employed when the impurities are less feasible than the metal. For example, tin, lead and bismuth are refined by this method. Tin, lead, bismuth are readily feasible metals. The impure metal is placed on the sloping hearth of a furnace and gently heated. The metal melts and drains away, leaving behind the infusible material on the hearth. Then, the second step is distillation process. Volatile metals, that is low boiling points like mercury, zinc and cadmium are refined by this method, while the pure metals distills over and the non-volatile impurities are left behind in the retort. Then the next step is oxidation process. Oxidation processes are employed for refining when impurities consisting of other metals get oxidized more readily than the metal itself. The impure metal is exposed in a molten state to the oxidizing influence of air in a suitable furnace. The oxides of the other metals which are formed are removed from the surface by skimming. Sometimes the oxide of metal itself is added, which provides the oxygen to the impurities. Thus, copper oxide is added to impure molten copper to provide oxygen required for the oxidation of the impurities. Then the next step is thermal decomposition of suitable compounds. In this method, the impure metal is converted into some volatile compound which decomposes easily to yield the pure metal. There are 2 examples are as follows. Number 1, Mons process. In this Mons process, impure nickel is treated with carbon monoxide at 50 degrees C, which nickel carbonyl gas is produced, which when heated to 250 degrees C in a closed vessel decomposes to give carbon monoxide and pure nickel. Carbon monoxide is recycled to react with more the impure nickel. This process is known as Mons process. Then the second example is Van-Arkel de Boer process. This method is used for the ultra purification of zirconium and titanium. The impure metal is heated with iodine to give volatile metal iodide. The iodide is then heated electrically in a closed container. When metal iodide decomposes to give the metal which deposit in the tungsten filament of the electric heater. The iodine liberated is recycled to react with further quantity of the impure metal. The tungsten filament is then drilled out, leaving behind the hollow bar of pure titanium or zirconium. Then the next step is electrode refining. A large number of metals are refined electrolytically. The impure metal in the form of blocks is made the anode of the electrolytic cell, while the cathode is a plate of thin metal, pure metal. The solution of a suitable salt of the metal is used as the electrolyte on passing the electric current. The pure metal goes from the anode to cathode from the anode and is deposited on the cathode. The suitable impurities go into solution while the insoluble matter settles down at the bottom and is called the anode mud. Then the last step is zone refining. This technique is employed for preparing extremely pure metals. This is based on the principle that when the melt of an impure metal is allowed to cool, the pure metal crystallizes out while impurities remain in the melt. In this technique, the impure metal is converted into the bar, which is heated at 1 and with a moving circular heater. The impure circular heater. The impure metal melts at this end, forms a molten zone. As the heater is moved slowly along with the length of the rod, the pure metal crystallizes out at the earlier metal zone while the impurities pass into the adjacent newly created molten zone. This process is carried out throughout the length of the rod. As a result, the impurities are completely driven to one end of the rod, which is cut off and discarded. The process is carried out in an inert atmosphere to prevent oxidation of the metal. This completes the various steps in metallurgical process.